Let's solve this question in stop and wait. They are asking that the bandwidth is given to be 1 Mbps and 1 bit takes 20 milliseconds to make a round trip, which means bandwidth is given to be 1 Mbps. Let me just multiply by 10 to the power 6 bps, and 1 bit takes 20 milliseconds to make a round trip, which means the propagation time will be 10 milliseconds only, because the round trip it is taking 20 milliseconds. Then what they are asking, what is the bandwidth delay product? So bandwidth delay product means like bandwidth into round trip time. So bandwidth is 1 Mbps and round trip time will be 20 milliseconds. So let me just multiply both. It will be 20 into 10 to the power 6 bps, right? So since it is millisecond, so let me convert this also to a second. Now it will be, your second and second will cancel out, it will be bits only. So bits, which means 20,000 bits. This is called bandwidth delay product into 2TP. So 2TP here is round trip time. If the system data packets are 1000 bits length, so length is also given to for the data packets, which is 1000 bits. Then what is the utilization they are asking? So if you remember, the formula for the utilization in stop and wait is utilization efficiency is this 1 upon 1 plus 2a, which means 1 upon 1 plus 2 into what is the propagation time? Propagation time is 10 milliseconds. And what is the transmission time? Transmission time should be length upon bandwidth. Length is 10,000 upon bandwidth is 10 to the power 6. So it is 10 to the power minus 3 seconds, which means 1 millisecond, right? So it is 1 millisecond. You need to divide by 1. Now you will be getting 1 upon 1 plus 20, which means 1 upon 21, which means like approximately 5%. If you multiply by so in the percentage, then you will be getting approximately 5%. So here in this question, what they have done, they have not used this one. Okay, so let's not worry about it. Some of the authors use this one, some of the authors doesn't use one, so they are exactly getting 5%. But like we will be going with this formula, and don't worry, in the exam like either they will be having the option with either with 1 upon 21 or with 1 upon 20. They won't be having both of the option, and if this is numerical answer type, then marks should be given to everyone who is using one and who is not using one. So let's not worry about it. But with this question, I want to convey one thing, is that this bandwidth into delay product and this A is almost similar. So if you notice this A, or let me just call it 2A, 2A is nothing but 2 into propagation time upon transmission time, which is just 2 into TP upon transmission time is length upon bandwidth, length upon bandwidth. So if you notice that this 2A and this bandwidth into delay product is almost same apart from this L. So you can say that this is just bandwidth delay product upon length of the packet. So basically, if you remember this A was number of packets that you can fill in the channel, right? Number of packets that you can fill in the channel. 2A is number of packets you can fill in the channel. Like if you are using 2 into TP, which means if you want to fill the packets in 2 into TP time, then you can fill 2A packets basically, right? So 2A is packets number of packets we can fill in 2 into TP time, or you can say 1 RTT. RTT means round trip time, or in 1 round trip time. These are the number of packets. And what is bandwidth delay product? Bandwidth delay product is just 2A into L. So these are the number of packets, and if you want to find number of bits, like instead of number of packets, if you want to find how many bits you can fill in this much time, so number of bits we can fill in 1 RTT. 1 RTT is just 2A. 2A is number of packets, and in each packet how many bits you have? You have L bits, right? Because packet length is L bits. So number of bits you can fill in 1 RTT is 2A into L, which is nothing but bandwidth delay product, which is also called as capacity of channel. This is also called as capacity of channel. Okay, so this two-way will tell you number of packets, but bandwidth into delay product will tell you number of bits. That's the only difference. It will tell you number of bits. Number of bits you can fill in one RTT is bandwidth into delay product, which is just 2 into L. I hope you got it. So if you want to find out in terms of packets, like your units are just packets, like how many packets you can fill in this channel, then it is 2A. And if they ask you how many bits you can fill in this channel, then you will say 2A into L, because one packet is having L bits. So 2A into L bits you can fill in this channel, which is also bandwidth into delay product. Okay. Now let's do this question. What is utilization percentage of link in example 23.5, which means the earlier example, if we have a protocol that can send up to 15 packets before stopping and worrying about the acknowledgement? So they are saying that what is the efficiency or utilization if you can send 15 packets before stopping. So earlier what we were doing, we were just sending one packet and then we were just waiting for the acknowledgement to come. So we can send 1 plus 2a packets, right? We can send 1 plus 2a packets, but we were just sending one packet. That's why efficiency was this. Now they are saying that in this case you can send 15 packets, so efficiency will be like this. Efficiency will be this. Why? Because we can send 15 packets, but we could have sent 1 plus 2a, that is another story, but in this case we are only sending 15 packets, so efficiency will be this. So it will be 15 upon 1 plus 2a means 20, which means 15 upon 21. So it will be around 75%. I hope you got it. So 75% is the answer. Now in stop and wait we do not do it, which means in stop and wait like formula for efficiency is this only, but there are some protocols which we are going to study next. In those protocols what we do, we send multiple packets at a go. Okay, so instead of just sending one packet and waiting for the acknowledgement, we send multiple packets in the pipeline protocols. So next we are going to study the pipeline protocols. In those protocols we send multiple packets instead of just one packet.